Hi, my name is Ben Flagg, and for my cell biology news presentation, I did an article in the Nature Science Journal. It's by Carrie Smith, where she is summarizing the research of 3 different institutions that have been studying the effects of a drug called rapamycin. Rapamycin is an immunosuppressant, and it is commonly used to prevent the rejection of kidney and liver transplants. An immunosuppressant is a molecule or compound that suppresses the immune system. So the reason why this drug is deliberately used in organ transplants is because it suppresses the immune system, so as to prevent the rejection of the transplant. So, just in case you didn't get that. So, basically the research for this experiment was done in parallel at 3 different institutions. At the University of Michigan in Ann Arbor, University of Texas Health and Science in San Antonio, and the Jackson Laboratory in Bar Harbor, Maine. They tested on over, together they tested over 2,000 mice, and they were specifically bred to ensure genetic differentiation, so that no single strain would be more or less susceptible to aging-related diseases, which was what they were studying for. And they administered the drug rapamycin through the food that they gave to the mice. So they chose rapamycin because it is known to have effects on the cellular pathway known as TOR, target of rapamycin. And so TOR proteins, they regulate the initiation and elongation phases of translation, ribosome biosynthesis, amino acid import, and the transcription of numerous enzymes involved in multiple metabolic pathways. So rapamycin inhibits the downstream signaling of TOR proteins, and these proteins coordinate the balance between protein synthesis and protein degradation, and in response to nutrient quality and quantity. So the results of their experiment showed that the lifespans of mice given rapamycin increased up to 14%. 28% for males and 38% for females. And what's interesting is because it took them so long to incorporate the rapamycin into the food for the mice, they actually didn't get to test on the mice till they were 20 months old. So they were actually given this drug at the equivalent of 60 years of age for us. So this little accident actually proved to be helpful because it increased their lifespan this much at such a late age in their life. And when asked the question of could this apply to human life, no, because there's a big difference in dosage. It's 3 to 5 milligrams per day for humans if we were to administer it to ourselves, and it's 2.5 milligrams for mice, and there's just too much fogginess, and it's a recently discovery. So, and so far we have no way of altering the negative effects it has on the immune system because it is an immunosuppressant. So it would leave the people who take it really susceptible to infectious diseases. So basically it was a pretty interesting thing, just a little breakthrough that these scientists were able to study mice and actually expand their life. So who knows what the future will entail.